data and AI consultancy, but ultimately by night, yes, I'm a data platform MVP. I have been for 9 years now. Feel free to connect with me on the usual social media platforms and things like that. Ultimately, the best parts of my job now, because my job is also a little bit my hobby, I think, is that I get to share that knowledge with you guys. Very much the favorite part of what I do. I'm very passionate about technology and what we do in this industry. So it's really great to be able to share that. And it's really great that the community that we have. I think this is my second or third time actually presenting to the Toronto meetup as well. So yeah, been doing this a while, and hopefully you can probably tell by the grey hairs on my head, I've got all of the battle scars from the IT industry. I'm 21 years old really, but of course we know what the IT industry does to us. On a more serious note, I can date myself in my career, which started in the NHS, the UK Public Health Service, with SQL Server 2000 and DTS packages and VB script, if any of you can remember that. I tell my children that I'm older than Google, which is fairly confusing to them because they can't imagine life without Google, which is quite amusing. I do know what a floppy disk looks like, and I also do know what a dial-up modem sounds like, and I confess to you guys that I do actually miss that sound as well. And if you wanted to go onto YouTube, you can find soundtracks of a dial-up modem. But hey, this is me. On to more serious things. So my topic and my agenda for you guys today is very much in the spirit of fast tracking your Lakehouse build with a metadata driven framework. So really all I'm going to do here in my agenda for what we're going to cover is I'm just going to break down this title into a few main parts, cover some of it in slideware, but then hopefully fairly quickly just get into the Azure portal, actually show you guys what this looks like for real if you wanted to do this as well. The first part we're going to break down is very much to think about what we mean by a lakehouse. Now, I'm not sure if this is obvious or not, but even last week I was having a debate with a customer on what was meant by a lakehouse versus a data warehouse. So I think it's important that we just clarify this as well. Now, given my career and where I started, when we think about what we're doing with that, and if we were to call it a data warehouse, the problem here hasn't really changed. We're going from some data source to some insight that we want to find from it. And the thing we're putting in the middle is what we might describe as the data warehouse, where we cleanse and curate, model, transform, enrich, whatever we want to do with that data. And as I say, this problem hasn't changed. The what and the why we're doing this hasn't changed. And we just described it in one way before. But of course, what's happened is now that technology has evolved. So the what and the why haven't changed, it's the how that's changed. And because that how has changed, because that technology has evolved, we now just need to think about that evolution, which is where our terminology has evolved with it. So if I was to move my slide on and think about that now and think about a similar delivery pattern of achieving the same thing in the cloud, really all we're doing here is now just decoupling the compute, the storage, the orchestration. On premises, maybe this was SQL Server that scaled up. Maybe now in the cloud, this is a bunch of different resources. And we're just separating out those parts because we have a big data problem generally to deal with, a big data problem that requires us to scale out the compute and the storage. So still achieving the same thing, but yeah, just an evolution of how we do it. So we might think about that pattern a little bit like this, where I've separated the compute, the storage, the orchestration in that journey. We could also think about it, if you don't like my picture, we have a version of the same from Microsoft. This is what Microsoft call the components of their big data architecture. Now, big data, of course, is generally relative, but ultimately you see the same thing here in terms of those components, our source and our analytics, our reporting, maybe over on the right. We've got orchestration in there, we've got some storage. Now, the only real difference here between this And my version was that we've just got that separation now between our batch processing layer and our stream processing layer. So thinking about whether it's a Lambda or a Kappa architecture as well, we do want to just think about handling both. So the problem, yeah, changed or not, whether it's data that's coming at us in higher volumes, high velocity, we're still achieving the same thing. The why is still the same. So if we move forward and we think about my picture, I'll call this my first reference architecture. It was a very proud moment in drawing this picture. So, I just tell my family that I am an architect for data. I just draw pictures, I do coloring in. It means that I don't have to fix their Wi-Fi. But here is my picture, and I show them this, and it's like, this is what I did today. Of course, to put a different perspective on it though, and actually apply some tooling in here and thinking about what we mean if we're now delivering that Lakehouse, we could put some icons on here for Databricks, for Data Lake, for Data Factory. All things that start with data. This is good. I like this. For me, this represents the mature technology stack that we could use to implement this solution. We could, if we want, use Azure Synapse Analytics. Now, given the product roadmap and obviously what Microsoft is now doing with Fabric, I'd probably not recommend this, but for the sake of completeness, this is a pattern and a technology stack we could use to deliver that Lakehouse. We could, of course, use Fabric as well, using the data engineering capabilities, using OneLake, using those data pipelines. So achieving the same thing. Reference architectures versus products, all to create what we want in terms of that Lakehouse capability, considering that evolution of what we're doing. Now, thinking about patterns, thinking about delivery, thinking about technology is fine, and the products that Microsoft and Databricks respectively give us. But what are we actually thinking about in terms of what goes beneath it, and why do we feel that need for that evolution in the naming? So for me, this comes down to what we now get from Apache Spark, the open standard that obviously was given to the Linux Foundation, that Databricks then founded themselves as a company for in 2013, and how that has evolved. Spark sitting over our Hadoop distributed file system in most cases, obviously now abstracted, implemented as Data Lake or as OneLake as you prefer. And we continue to add to this stack. We continue to add to it if we think about including our Hive Metastore, including our Jupyter Notebooks as that IDE to actually interact with Spark. Very importantly, thinking about what we now get from Delta Lake as an open source storage format that gives us those ACID transactions over the top of that. Writing our code against this in different languages, having that ability to share that data, connecting our dashboards and Power BI, using things like Unity Catalog to give us that view across all our workspaces maybe in Azure. Doing things now whereby those ACID transactions and the metadata that supports them doesn't just have to be defined using Delta Lake as the structure, but if we think about what Netflix and Uber gave us in terms of Apache Hudi and Iceberg, frameworks also to deliver that ACID transactional resilience over our data lake storage. Databricks now extending data lake with what they call uniform, whereby they're uniforming the format of that data so we can access it and we can work with it wherever it may be. It doesn't matter. We then bring our friend SQL to the table and we use that as well. So evolution just in how we operate and evolution of that tooling. So to my point earlier, if we think about what we mean here by a lakehouse and what we want to achieve, we're ultimately going from a pattern and a solution that might look something like this with our databases, with our transactional data, our OLTP data, taking it into a warehouse, doing that reporting, gaining that insight. But it's that evolution of how. That evolution of how from a warehouse to a lakehouse. And this is really all that we're going after at this point. So maybe obvious, maybe some of you know it, but I do still encounter situations where there's a little bit of clarity needed. on what that actually means and why we start referring to things as a lakehouse now, not a data warehouse. We're just using the English language, we're torturing the English language, which of course we love to do. We could, of course, debate what we mean here with extract, transform, and load. For me, my career started with this concept of ETL. ETL was fine. We understood the objectives here from an engineering perspective. If you want to be cool, you're very welcome to rearrange the order of these letters. I don't mind. You can put other letters in there as well. But of course, the intent is the same. The problem is the same. So, our lakehouse. And ultimately, this is the thing that we now want to do. So if this is the technology we're targeting, this is the thing that we now want to look at, we want to build that. And for me, as part of the session this evening, this afternoon for you guys, we want to build that with a metadata framework. So for me, just to complete the picture here and to try and kind of make the point, for me, we are doing this, we're bringing together that compute and that storage, we've got that ACID transactional processing that we want, and when it comes to that metadata framework, for me now this is just an abstraction over all of that tech, all of those things, and we're delivering that with what we would call Cumulus. Now, this is not a sales pitch because Cumulus is an open source tool. It's available on GitHub. You can go and do this today if you wish. There's no obligations whatsoever. It's just giving you guys as a community the abstraction to actually build out the solution without necessarily needing to worry about some of the complexities that go into all of the icons on my screen, all the complexities that also go into the other product aligned resources and things that Microsoft give us with Databricks and Fabric and Synapse. So just abstraction to achieve the same thing is what we really mean here with that metadata framework. So Cumulus then, let me introduce you to Cumulus, and I'll start with a picture. Again, architect, draw pictures, this is very much my job. So thinking about that same problem, obviously evolving from my first reference architecture, but what we have is our sources, no change there, and we're consuming them. Producers and consumers. So Cumulus, that Lakehouse accelerator, that metadata framework, is the bit that's occupying that middle. It's giving us that ability to connect those producers to the consumers. And the internals of Cumulus, what we describe as ingest, transform, and control. And those are the modules of Cumulus that make this possible, that make the delivery of that Lakehouse possible. This is obviously a deliberately very generic kind of diagram, a very generic picture, because we can obviously do this in lots of different ways now. But just to go a level deeper, if we think about what we're doing with the ingest module, metadata driven, very importantly, we can adapt this to lots of different scenarios. We can use and connect with lots of different data sources. We can deal with that change data capture process. We can do full and incremental loading, and we can push down queries to those source systems that we want to work with, very importantly. So through that metadata abstraction, giving us everything that we need to get from that source system into our Lakehouse storage, into that raw or that bronze state, and into that cleansed state as well through a merge operation. Now, just as an aside, whether we call this raw, cleansed, and curated, or bronze, silver, and gold, I don't mind. Both are applicable here. Business users like to call it bronze, silver, and gold because generally they know that gold is better than silver. For me as a data engineer, I like to think of it as raw, cleansed, and curated. So I like to know that cleansed is now doing something that raw isn't. So depending on your perspective, we're achieving the same thing. We're just enriching, curating that data. Moving on, our transform module, metadata driven again, very important. Metadata is the abstraction. Rapid engineering, applying that business logic, easily adding it into the solution here using Spark SQL. Sorry, was there a question or just somebody not muted? I assume not a question. I'll move on. So the transform module giving us that same capability, very flexible, adding notebooks in here to support the business logic that we need to apply. and then getting that data into that gold or curated state. Lastly, the control module, metadata driven again. Of course, I'm going to keep saying this, data about data. To support that orchestration, to give us that managed dependency chain, to deal with our concurrent executions, to give us the logging, the restartability, everything that we actually need now to invoke our ingest pipelines and our transform pipelines to get that data moving. So control, as it's depicted in this diagram, there to look after what ingest and transform does. So those are the modules that are going to go into this framework that's going to help us build and accelerate that Lakehouse delivery. Now, just one final point on this, depending on how long you've been following my blog or following my work, but just for wider context, I, once upon a time in a galaxy far, far away, also created and put out what I call a proc framework. That was another open source project on GitHub. That does still exist, but it's no longer supported because of the function apps and things and the .NET libraries that were used. But just for information, that control framework has now been upgraded, adopted, and now included in this new open source version of this Lakehouse accelerator. And that proc framework now represents the control module of Cumulus. So just for information, I say you might already be aware of this. Excuse me, my throat is drying up. So why do this then? Well, we want to accelerate, but not just obviously with the product in its generic form, but we want to utilize all the things that we talked about with Spark, with data lake storage, connecting the producers and the consumers. And if we peel back that very generic kind of set of icons and things a layer deeper, this is what we end up with. Our orchestration pipelines, our metadata to drive all of this stored in a SQL database, our worker pipelines for doing the ingest and transform work, our Bootstrap pipelines to support the control and the orchestration, Spark for the compute, data lake storage. Now, really important for us, open source, open standards. This is where we want to be. We don't want to be locked into necessarily any proprietary technology, although we could argue that when it comes to some of the middleware and the pipelines, sure, maybe. But generally as an ethos here, thinking about what Apache Spark gives us, think about that data lake structure. This is where we want to be, aligned to those open source and open standards, because this is good for the community. This is good for us. It's good that we can collaborate. We can do this together. And as I described earlier, this is just about abstraction as well. So considering that, what this means is that we could now actually implement this framework using a different technology choices depending on what we want to use. We could do this with Synapse, we could do this with Fabric, we could do this with Databricks and Data Factory. And Cumulus as that metadata framework is providing that layer of abstraction to make this possible. And these three columns here, they don't have to be exclusive. So through that middleware of the Azure functions, we could, if we wanted to, orchestrate Fabric pipelines from Data Factory and vice versa, and Synapse pipelines from Data Factory and Fabric, and completely interchangeable at this point in terms of that orchestration layer as well. So it's a metadata framework, but it's giving us that abstraction, it's giving us that acceleration, that simplification of what we want to do, and then also getting us to where we want to be in terms of delivering that to fast track that Lakehouse build ultimately. Any questions briefly before we move on? I'll just have another sip of my drink. I'll take silence as no, all good. So we've thought about the Lakehouse part, we've thought about the metadata framework part of what we want to do and why. Let's now tackle the fast track part of this. We want to do this quickly. So my advice for you guys and what I've included in the slides is here's the URL that you want. So go into GitHub, go into CloudFormations, go into the Cumulus repository, or via the QR code if you prefer, if that's helpful or not. Otherwise, we'll stick this URL in the chat. And then once we get there, You probably want to clone the repository. You want to use VS Code as your IDE. You might want to install some extensions. You might want to check the resource providers and things in Azure, depending on what you might have. But ultimately, there's some bicep in there that will allow you to go and deploy this, do all of that stuff for you fairly easily and get to where you want to be. And then once you've executed that bicep, you will then get a community edition of CF Cumulus with all of the stuff in there that I just talked about. So let's do that. Let me just change my screen around a moment and share this one. So all good development projects start with Google, as I'm sure we know. But as mentioned, for you guys, my advice here, CloudFormations, go into that Cumulus repository. I'll also put a link in the Teams meeting chat for you as well for ease. So we can go in here and, you guys, as you prefer, clone it, use GitHub Desktop, etc. I don't mind. But ultimately, we want to get that and we want to open that up in our preferred location. And what we have then is a VS Code workspace that we can have a look at. So here's one I made earlier. Now, for you guys, if you want to open this up, you want to go to the infrastructure folder. We want to go to the bicep. And what we've got in here is all of the bicep modules and things to do the deployment. Now, I'm not going to take credit for any of this. So also on the Teams call is my colleague, Matt Collins. He's actually one of the product engineers that actually has worked on this and takes all the credit for doing all of this good stuff. I'm just here to make it look pretty with slides. Matt's done the hard work here. So reach out to Matt in the chat as well if you've got any questions as we go through. Ultimately, though, what this means is to fast track that journey for us is we've got all the bicep we need to do that deployment. Now, I don't know how familiar you are with bicep, but for me, the favorite part is being able to visualize it. And as I said, love a picture. So we have the bicep visual. Look at that. How beautiful is that? Beautiful, but generally not very useful. But it does kind of give you a clue of all the kind of parts that are needed here to make Cumulus possible. So what you might have spotted is that this is going to use that third column implementation that I talked about, the resources we're targeting here, Data Factory, Databricks, Data Lake. For me, those are the mature and recommended offerings of what we want to work with, still using that SQL database for the metadata, but not using Fabric just yet until it gets a bit more mature. So I've got my bicep, and you'll also find kind of the same instructions in the README file of this GitHub repo as well. Everything I've just kind of skipped through here just for demo purposes. So we do this. We also want to go into our config. We want to just look at our installation. We want to think about some parameters that we want to set in order to execute this. So for me, I'm just going to call my organization CF for ease. We're going to have a domain called Toronto, because this is all good. We're going to do this dev, and we're going to target the UK South region here as well. So I've set those parameters. I've got my pretty bicep, but of course I've got all of the modules and all of the actual hard stuff that kind of goes into doing this. And for me, for ease, I'm just going to deploy the bicep file for you guys just as an example. Give it some information about the deployment. I'm going to pick my Visual Studio subscription. Yes, we're going to go for UK South. And yes, I'm going to use my, no, I'm not, just remembered. I did this earlier, just as obviously to test before speaking to you guys. I am just going to increment this by 1. So we're now deploying to 0.2, just so we don't get any conflicts, because I can't remember if I deleted it. Let's do that again. Deploy my bicep. There is also a PowerShell file and a wrapper that does some of the clever stuff as well, but I'm just going to use the bicep now just for ease and just for demo purposes. And we are off, waiting for deployment to complete. So obviously in the spirit of transparency here, the other thing just to note, I said about fast track, so we do want this to be relatively fast. You'll see when I did this earlier, so 11:50 your time, I just kind of ran this just as a bit of a test. When I ran this earlier, it actually took about 5 minutes to do the bicep deployment, so I'd call that pretty fast. So we did that earlier, and obviously now we're just kicking this off again as well. So let's just have a look and think about what that's doing in the Azure portal. So I'm going into my Visual Studio subscription and going to my resources. I'm very impatiently just going to keep hitting refresh a little bit on this, but we've got that Toronto 02 named resource group here, and we're already starting to get some of the resources and things deployed. If we just go to the deployments view, again, I'm very impatient. I generally tell people that the more times you hit refresh, the faster this will go, because they believe me when you say things like that. But we get all of the stuff that we actually need to generally make this possible. And the PowerShell version that's in there as well that you'll find from the GitHub instructions just gives you that kind of application level stuff as well beyond the bicep resource deployment. But ultimately, this gives us everything we need in that resource group for our Lakehouse. Now, I won't use this version. Obviously, we'll play the game of here's one I made earlier. And for that, I'm actually just going to drop over to a demo environment that we've already got created, just to give you guys a bit of a tour of what's in here from a resource perspective as well. So we're still targeting that very generic picture, but we're obviously now into the implementation of what this actually could look like in Azure, using Data Factory, using Databricks, using that metadata in a SQL DB. So as we're data people, perhaps the best and the first way to look at it is if we open up that metadata database in Management Studio. I'm still using Management Studio version 20 because I opened up version 22 and I thought it was horrible, so I closed it again. So we're in version 20 and we're looking at a database diagram for that. And just to give you guys a quick view of what's in here. So similar to how I described this journey in the slides, we'll start just by thinking about our ingest schema. So tables in our schema are aligned to the modules, aligned to the product, hopefully keeping everything straightforward here. So we want to ingest some data sets from our source system. And hopefully, as you'll see from the attributes, we're describing that metadata with everything that we might need. This demo environment is set up to work with AdventureWorks, which I hopefully you'll agree is the best sample database in the world. We don't want New York City taxi data or anything like that. AdventureWorks and bike products is where we want. So 3 tables, our order headers, our order details, our products. For any of you that have looked at AdventureWorks, I'm sure this is familiar. So we are bringing this in, we're defining those data sets, we're setting information about our loading type, if we want it full or incremental, what we might want to do in terms of that change data capture behavior to pass in a custom load clause to the source system and get back only the records that have updated. Of course, not really realistic for sample data, but you get the point. So we define our data sets. We also define our attributes that then tell us information about the primary keys, about our data types and things that we want to do things with, because of course in the context of this source system, we're going from T-SQL data types to what will ultimately be persisted as Spark data types in the resulting data lake. So data sets and attributes defined, nothing too scary or exciting there, and there's lots of ways, of course, you could scrape that metadata from the source system, bring it into Cumulus very easily. What I'll call out next is our connection information. So Not credentials really at this point, but connection information that helps us understand where we're actually going and fetching this data from. So our AdventureWorks demo database, in the case of my example here, we have connection type information. Is it SQL? Is it Oracle? Is it OData? Is it something else? Is it Dynamics 365 and we have to query it with XML, etc., etc. So yeah, depend on your source systems. And then if I just close a few of these, so connection types, connection compute, I'll come back to momentarily, but thinking about how I described it again in the slides. So that's our ingest metadata that we need. We have our transform metadata, so where we actually want to do that work to curate the data. We define it with attributes that can top and tail the notebooks, so where we're going to apply that business logic. We think about the notebooks that we want to work with. We think about the attributes that we're going to use in there as well. So I'll describe this really from the perspective of the metadata firstly, then we can look at Data Factory and Databricks, and it'll hopefully then become clear for you. So I'll transform metadata, and then lastly, what I'll show you in here is our control metadata. So very much that PROC framework that you might have seen before. So we have a hierarchy of things happening here for that control framework, where we have our batches, which could be daily, weekly, monthly, as you prefer. We have execution stages. We could describe them as extract, transform, and load if you wish. We also have our pipelines. So the pipelines is that lowest level unit of work that we actually now want to go and invoke through this framework. And these could be ingest pipelines, they could be transform pipelines, they could be some other custom pipeline that you've already got that you just want to run as part of this and to do something else. Absolutely fine. We define some pipeline parameters that we do want to pass to these workers at runtime. We put that into the metadata as well. We also define some dependency information. So where we have upstream and downstream dependencies, thinking about that horizontal execution, thinking about that referential integrity as well, separating those vertical execution boundaries through the stages with other dependency information to support that failure handling. We put that in here too. We can, if we wish, provide some other authentication information if we need to orchestrate this across different tenants, across different subscriptions. But for the sake of this, we'll just assume that we are, of course, all in the same tenant. So this is how we're then handling that orchestration based on some of that work. So that's the kind of the metadata perspective of it. If we go back to our Azure portal and we think about the internals of our data factory next. So some pipelines. So I'll take the same pattern for ingest firstly. So if we think about getting that data from the source system to that raw or that bronze layer, I said we're looking at AdventureWorks. So let's think about the SQL Server version of that. So this is very much the pattern of ingestion that we want to use and that we can then reuse every time. And we've got a switch activity that just determines the different authentication that's going to be used and copy activities in here to do that work. So depending on how familiar you are with Data Factory, but we've got our source, we've got our sink, everything in here is parameterized and dynamic, driven by that metadata. And what we do is we have an ingestion payload. So that ingestion payload is simply getting that information from my metadata. So we've got a store procedure in here that is accepting a dataset ID. So if I've still got my tables open, if we just think about that order header as an example, we look at our ingest and we're getting, not that one, we're getting that dataset payload. We can just run this. Ultimately, it's gathering up all of the metadata for the datasets, the attributes, and we're passing it in to the pipeline to then go and do the work and that source query as well. So we're just passing around a single dataset ID at this point, and that's what's going into this pipeline for the execution. We then do the copy, and everything that we need then flows through and we get that data landed into our data lake. So we can come back to my dashboard, we can go to my data lake storage, we've got our raw cleanse curated, again, bronze, silver, gold, don't mind, but we've got our AdventureWorks data, we've landed that sales order header, we've versioned, we've got full and incremental loads, and we've got the typical partitioning as we've defined it here for that data that's then been ingested at that point in time. All metadata driven. I've not had to do anything else in here because the data factory pipeline is handling all of that. Once we've got that data into that raw state through this process, what we're also doing as part of the ingest is that merge operation. So very importantly, taking it from the raw into that cleansed state. And we're using Databricks in this case to do that, because of course we don't want a Parquet file structured in this way. If I come back to the container level, what we want to now do actually is following a similar structure, but we want to get very quickly to that Delta Lake table. So we've then got that ACID transactional resilience over that data set, and we want a merge to handle that as part of the work that's being done. So from a data factory perspective, we similarly pass around a dataset ID. We get that payload. We go into our Databricks workspace. Let's do that. And in here, we've got all of the boilerplate code in the notebooks to support that journey as well. So in my files for ingest, we've got some utilities that support the dynamic creation of that merge. Again, Matt gets all the credit for this. Matt's created all of these notebooks to make this possible. Utilities that do this work, that ingestion payload, and then we do some work in here as well to check that, but ultimately we just go through the motions in the notebook to execute, obviously scrolling down just given the time we've got now, but basically cut into the chase. We run the merge, we do the work, we process everything dynamically based on that metadata. We don't need to know Python, we don't need to know Scala, we don't even need to necessarily open Databricks if we don't want to, because we're just defining T-SQL metadata, we're running the data factory pipelines to make this possible. So in theory, let's assume we've gone through all those motions in our storage and our cleanse layer. We've got everything that we need there from our AdventureWorks database. We're now going to go and build out some facts and dimensions because we like a Kimball dimensional model, and that's how we want to report on it. If we're doing that, we want to think about using our transform module to do it. Now we have this concept here of managed and unmanaged notebooks. An unmanaged notebook, quite simply, is just taking whatever you define for your notebook and just wrapping it up in the framework, targeting your preferred Databricks cluster to go and run this and to kick off that notebook. Nothing more is expected. What we do in our managed notebook, though, is slightly more interesting. Now, we can't avoid that business logic. We have to define that business logic somewhere. But what we're trying to do in the framework is take the pain out of what that actually might look like for you. So we hope that if we want to define something like our fact sales, if we know T-SQL and we can create T-SQL in the metadata, we can create some Spark SQL in here to create what we might need as that output for it. So a simplistic example again from AdventureWorks, if we're creating some sort of fact sales, but what this means is that we can just write some Spark SQL, and then through the framework, all of the header and the footer information, all the data frames, all the tables, all that other stuff that then supports the input and the output of this fact sales is taken care of for us. And all we actually then need to do in the transform execution is just go and get the business logic that's been defined. So we're also fast tracking that Lakehouse build by saying that if you know SQL, T-SQL or Spark SQL, you can get all the way through the steps here without necessarily needing to know everything about Databricks, because through that abstraction, it's taken care of for you. So we might go and do that. Transform, of course, goes and runs in theory, and we get to a point where we're actually now got curated data, we've got some facts, we've got some dimensions, and if we wanted to, in our Databricks environment, or as you prefer, using your endpoint, using your compute of choice, we could then go and interact with that again with SQL to consume that data as well. So ingest and transform kind of covered off, and we've got those outputs here. We've got that, and we could actually start doing some visualizations and things if we wanted to, even directly in Databricks. Or apparently not, because my serverless pool is not authorized. Maybe the token's expired, but we don't need that. We're not doing any dashboards at this point. Last piece of the puzzle, though, just thinking about it from a data factory perspective and given the time as well, we want to think about that control part. So we want to deal with that hierarchy. I described it in the metadata earlier here. I said we've got batches, we've got stages, we've got pipelines. So if you think about what I then need to do based on that metadata that I've created and how it's actually going to invoke the pipelines, how it's going to invoke the Databricks notebooks, what my pipeline metadata is going to look like to complete the picture is something fairly simple. Because it's all boilerplate code, we're just using that ingest set of pipelines. So I had sales order header, detail, products. We're calling it 3 times, 3 different sets of metadata. We're doing that merge operation. We're using some transform managed notebooks. And, in theory, we're done. Very crudely speaking, we've got extract, we've got transform, we've got load, simplistically. But this is what this could look like, and this is how we've got those stages defined in here. We've, of course, got those pipeline parameters in here as well that we're going to go and run. We're just passing around dataset IDs for different things, for different pipelines, not complicated. And in Data Factory, we might start with our batch execution. Now, the way this has been set up is that we have a batch level executor aligned to the metadata. It will go and check if things are running. It will do some metadata integrity checks for us. It will ultimately go and set up and bring together all of that execution metadata it needs to now go and run those stages. And it's then going to go and actually start iterating through them, because those stages represent those vertical boundaries. Everything in a stage can be executed in parallel. If we go a level deeper in here and we look at the stage execution, so similar to the metadata, we're just getting the pipelines that we want to run in that stage. We're using the Data Factory's natural behavior of parallelism here from a pipeline execution perspective. And from there, we just parallelize the execution of a worker. And we have a pipeline executor to support that. So just 3 levels in, this pipeline executor is getting everything it needs, all the parameters. We're validating that using the Azure functions. We are executing in an asynchronous way. And this is where these functions come into their own as middleware, because it gives us that decoupling between the bootstrap level pipelines and the workers that we want to go and call, because they could be in Fabric, they could be in Data Factory. Functions make that possible because via the other methods, the other activities that we get in Fabric and in Data Factory, although we can make some of the pipeline naming dynamic, we can't make the parameters that we pass to it dynamic. So this is where the functions help us. We call that worker, we say start, here's your parameters, go run. Once that's returned, we then just iterate over and we just start polling and we just check if it's finished or not. Completed, failed, cancelled, successful, hopefully. It doesn't matter, we don't mind. We then report that back to the metadata. Maybe we do some alerting if we want to, but then at that level, we return. If we complete everything within the stage, we bubble up to the batch, we execute the next stage, and we carry on. So this is what we're now getting as part of that, and again, just using metadata to drive everything that's in here. So if we think about that from everything that we've talked about, we've got an open source project, we're in GitHub, we're deploying this with some bicep, in my case, just for demo purposes. We're getting everything that you then need from that Cumulus solution. You could go and add some AdventureWorks metadata in here as well, but then it gives you that ability through the metadata to quickly onboard the data with all of that boilerplate code, with all that metadata and abstraction in there as well. Based on the fact I've got 8 minutes left to finish talking to you, I'm just going to reshare the slides because there's just a couple of nuances just to kind of finish up. So yeah, we talked about fast tracking. I will just touch on storage layers for a moment because again, sometimes there's a bit of contention here on what we actually do. I'll just bring up this slide for you to look at while I just have a quick sip of water. How you define your storage layers, entirely up to you. There's no hard and fast rule here, of course. It's just about how you want to curate that data. My only advice is that, depending on what you do, have some characteristics, have a medallion status. This is not medallion architecture, it's a medallion status because it implies what we actually mean by the data that's in here. So I talked about raw, cleansed, curated. Sure, we could have other semantic models, we could have other landing zones, we could have rejected data in here as well. But this is our starting point. What I'll say to you is, based on the demo that I showed you today, the natural alignment of these storage layers to the Cumulus framework that could help you accelerate this journey is very much the fact that ingest is supporting the raw, the bronze, the silver, the cleansed, getting that data in whatever form it was from the source, merging it into that silver and cleanse layer, transform, generally looking after that gold and curated outcome. It doesn't have to be. Of course, if you want to do something different, we could evolve the picture. You could use that transform module to apply business logic to conform your data sets in those earlier layers. Absolutely fine. No hard and fast rule here, but this is what you could do, just for information. What's the difference between a medallion architecture and a medallion status? None, to be honest. I just don't like the term medallion architecture. It's not an architecture. It is just a taxonomy. It's just a classification. It just helps us inform what we're doing with those storage layers and how we curate that data. So there's no such thing as a medallion architecture. There's just a medallion status of how that data lake is organized, in my opinion. But yeah, good question. So just to wrap up for you guys, I mentioned, Cumulus is open source and there's routes here to deploy that via that community edition, which is what I've showed you. Please go ahead and do that. Of course, if you do want help, you want support, we can have a conversation about it, but that's not my intent here for this evening. It's very much for you guys to do what you need to do. So hopefully within an hour, I've given you a good tour of what's possible here to fast track your Lakehouse build with the metadata framework, and here's how you can go and do it. Any questions? I've got a clapping reaction. Thank you. I'll take it. Otherwise, I'll just stick the last slide up as well here and say thank you for listening, and obviously please reach out. I thought I saw a raised hand, maybe not.
There's no question in the chat.
Silence, stunned silence. I don't know if that's a good thing or a bad thing.
All right. Thank you so much, Paul. That was incredibly insightful session. You're giving us a lot to think about and apply. So, do we still have? So there's no question in the chat. Okay, so
everybody's happy. Either that or they're just eating their lunch and then out asleep.
Yeah, I know it's lunchtime. We're going to go back to the office in 5 minutes. So a big thank you again to you, Paul, and also a thank you to the cloud formation team who sharing their expertise with us today. So a quick reminder, our next event is Wednesday, April 18. Yes, so keep an eye out for the announcement and make sure you register early for that event. I would like also to thank you everyone for spending their lunchtime with us today. So Paul, anything else to add before we close the session?
No, all good. Yeah, please don't hesitate to reach out to me on email. Always happy to have a chat and hear your perspective on things. And ultimately, as I mentioned at the start, this for me is the best part of this community that we have, because we can collaborate, we can share knowledge, we can evolve together. And for me, this is why we do this with open source tools, so we can support that collaboration. So yeah, thanks again for having me.
You're very welcome, Paul. So everyone have a good rest of your day, and we'll see you next month. Thank you.
Bye for now.
Bye, everyone.